Hello everyone, welcome back to Everything Swift. Today we'll be tackling LeetCode question 100 titled Same Tree. And we'll be doing another question in this video as well. So we'll be doing two LeetCode questions in one video today. The reason why I'm doing so because the answer for these two questions is very similar in style. So I thought it would probably be a better idea in terms of understanding the pattern of the answer to solve both of these questions. And I think it's a pretty common answer style for any kind of like binary tree question. So hopefully by doing these two questions in the same video help you guys kind of like recognize the pattern, right? So let's get started with LeetCode 100 titled Same Tree. Essentially, we are given two trees represented here by P and Q. Our job for today, the task that we're supposed to solve is to determine whether this P and Q are exactly identical, right? So basically, in this example here, it's true because the root is 1 for P, Q is also 1, left side of P is 2, right side of P is 3, Q's left side is 2, and the right side is 3, right? So basically, what do we need to do first, right? We know for sure that we will have to traverse this entire tree, both of them, right? As we traverse them, then we are supposed to check whether their values are the same. If they are the same, then, well, they are the same tree. If they're not, then they're not the same tree, right? So let's go ahead and try and solve this. If P equals to nil and Q equals to nil, then basically there's no tree for us to check. I'll just return false here. Uh, let's see. We are going to do a helper function here. I'm just going to call it check, which takes P, tree node, and Q, uh, tree node as well, optional type, return boolean, right? So what's going to happen here is we created this helper function because we're going to do it in a recursive manner. And it's a very common pattern for us to recognize. Recursion is usually very helpful for tree-based questions. So just keep this in the back of your mind when you approach any tree problem question. Try and think like, especially regarding traversal of the tree, you probably would have to somewhat consider using recursion style, right? So here I'm just going to pass in check P and Q. And then over here, what I'm going to do is I'm going to put a guard statement here. P copy equals to P, and let Q copy equals to Q. Let P copy Q. Sorry, yeah, that was right. And then what I'm going to return here is, I don't know whether it's true or false, but I'm just going to do an operator here to check the equality of both the tree. So it is represented by this tree symbol here, tree equal sign symbol, to check for the equality of two objects, right? Okay. And oh yeah, just a recap here. This is just kind of like my habit to sort of like build those kind of fast optimizer check here. So if both three are nil, then we basically just exit out from this function scope. We don't even have to come to this return check function. But in the world of LeetCode, we probably would not get this unless specified in the question. But it's just a habit of mine to kind of like get used to the real world scenario where these parameters could be new, right? So what we are going to do here is we are going to check, right? If p copy dot val, right, this is the value of the node, equals to q copy dot val. So sorry, I'm just going to make it if they're not the same. If they're not the same, then we return false, right? Because we're supposed to find whether they are the same tree. If the value is not the same, that's it, right? It is not the same tree. But if they are, if we do not fulfill this if condition here, then we have to continue recursing it. And what we're going to do here is we are going to pass in the left and the left copy of both trees, right? And check q copy right and q copy right. So this is the recursion pattern that I'm talking about here. So we are calling this function here, right? We are calling the same function internally here. So it's going to be recursive down, and if we take a look, we are traversing the tree, right? P copy dot left will come to 2, q copy dot left will come to 2, q copy dot right, and oh, there's a typo there. P copy dot right and q copy dot right. P copy left, q copy left, right? So we are basically we are traversing the tree through this recursion, right? Yeah. So throughout the recursion, if we detect any value is not the same in their nodes, they are not the same tree, right? So let's go ahead and run this, and that's true. Let's try and submit this. Hopefully we got it right. Oh, that's not correct. Let me just return true here. Let's try and see this, and it's accepted. So previously basically the question is sort of like accepting that if both of these are nil, then they are the same tree, right? So I didn't know that it is that case, but yeah, that's the only fix here for us to get to the right solution, or else the logic is correct, right? So let's go to the second question now. It's called Symmetric Tree, question 101 on LeetCode as well, right? So we're going to do the same pattern, but the trick here is we want to check whether it is symmetry or not, right? So we only have one tree. We're supposed to detect whether they are symmetric or not, right? So as you can see here, one, well, basically it's just one, and then the left side and the right side of this child is 2 and 2, so that's good. 3 here, which is left, if you want it to be symmetry on the right side, it has to be the right instead of the left, right? So just notice the difference here. Well, basically, it is like essentially we're cutting this into half and placing a mirror. If they kind of like just flip to the opposite side, then it is symmetrical, right? So our task is to determine whether the given tree it is symmetrical or not. So I'm just going to go ahead again and check if the root is nil, then I guess I'll just return true here, knowing from the previous example. Yeah, so just a fast optimizer as always. If there's nothing to process, don't process anything. And then here we are going to do the same kind of style, a recursion format as well, where I'm going to check left node and right node, right, and return full, right? If left, just going to use guard here. If left copy equals to left node and let right copy equals to right node, else I'm just going to check left node equals to right node here. And just the equality, this is not a typo here, this is just to check whether both objects are the same, right? Then what we're going to do here is if the values are not the same, so it's pretty much this kind of similar like before. If copy left dot val is not equals to right copy dot val, then we return false. But here's the twist here, right? Let me just remember to call this function in the main code. So for the first one, I'm just going to pass in the root because we want to check the first one. So just pass root and root. But over here, we're going to do the recursion. So we're going to do check root dot so left copy dot left, and then right copy dot right, and then check left copy dot right and right copy dot left, right? So that's how we do the symmetric checking. In the previous example where we check for the same tree, we pass left, and here is supposed to be left as well because we are referring to the same like node, right? But because we are doing symmetry here, left and right. We have to check whether it's the same symbol. So when we recurse, we are sort of like doing the opposite. The left copy is passing the right, and right copy is passing the left, and same for left copy of left, we'll compare to the right copy of the right, right? And it's the same thing, we're going to traverse through the tree. If they are not the same, the value wise of the node, then well, it is false, right? So let's go ahead and run this, and hopefully that's right. There we go. Let's try and run this. And there we have it. It's successful. That is the correct answer. So yeah, these two questions, similar pattern. That's why I chose to do it in the same video here. We're using recursion. Just the twist here is in the symmetry, we're passing left and right, two opposite side of things while we traverse recursively. And in the same tree, in this question here, we are passing exactly the same left and left because we want to identify if it's exactly the same tree rather than symmetry, right? So that's just the only difference between the two questions. So yeah, I hope that this kind of video is helpful for you guys. If you guys feel that it is useful, please feel free to subscribe to the channel. Please help to spread this channel to your friends or any Swift enthusiasts. I'll be posting more video from here on now. And as always, thank you so much for your time. Take care and bye bye.